What's up, guys? It's this is welcome to Do Engineering here. I'm Robert, and this channel or the content on this channel is basically to help inspire, the next generation of engineers, and also to help engineers that are now starting the degrees, especially engineers that are connected to my field. So, automotive engineers and mechanical engineers mainly. I guess you could say aerospace engineers too, that are starting and basically, if you want to have a perspective of applying what you've learned, because when you go into first year, you learn all these thermodynamic cycles and you don't know how to apply them in practicality or in industry. So yeah, I'm doing this to just I'm just trying to bring up different topics and in thermodynamics especially, well, for starters, where I can try and link it to practicality, to maybe someone would understand at least, and it would help you gain understanding and to be able to link it with the theory that you've learnt in your course. Okay, so yeah, let me just say, okay, I've studied automotive engineering. So first year I was, and second year I was very much involved in a lot of thermodynamics. So, but ultimately today the video I want to start off with is I want to talk about one of the thermodynamic cycles, which is the Brayton cycle. And I also want to talk about gas turbine, because that's another topic that's mentioned in the in thermodynamics. I do believe doing it. I studied that briefly, but it wasn't a large part. But some of you might study the gas turbine in great detail. So hopefully this video helps you to understand how the gas turbine works and why the Brayton cycle is very important in the gas turbine industry, should I say. So okay, so anyway, let's begin. Right. So the Brayton cycle is obviously a thermodynamic process, and in short, it has four processes, or four, yes, let me say four processes. It has the compression stage, the heat addition stage, the expansion stage, and the heat rejection stage. So, and ultimately, the air, how it works is this: you have air coming into the compressor or the compression stage, and which is compressed to high pressure, and this air then goes into the combustion change, heat addition stage, where it mixes with fuel, and the fuel creates these gases, which then go on to the turbine to be expanded, and then some of it goes to the exhaust, and the rest of it goes on to, let's just say, create power. I'll explain that as I go along. Okay, so firstly, I want to talk about what we know as or what we know as the ideal cycle and the real cycle. So in Brayton cycle or in thermodynamics, whatever, the ideal cycle is basically this. Is let's just say it's the perfect cycle. So there are, it's basically all the processes involved are reversible. So you can reverse everything that happens in an ideal cycle. So heat rejection you can reverse. You can reverse frictional tension or whatever happens. Anything that creates losses can be reversed in an ideal cycle, but that's not realistic. We know that. So and that's what is in your textbooks. It's the ideal cycle is what you learn in the textbooks, but in the real cycle, there are no irreversible processes. All the processes, none of the processes can be reversed. I mean, if you compress the air, I mean, how are you going to uncompress it? Do you understand? If you when you create the combustion, how are you going to get the fuel back? You can't do that. You can't really get the fuel back, or the air. You can't really separate the air and the fuel again after you've created the combustion. So obviously we understand that, you know, that theory, what you learn in the textbooks isn't what's happening in the industry or in real life. That cannot happen. You need to have losses. It's thermodynamically just impossible to have a heat engine or an internal combustion engine that has no losses. It's just not possible. Heat has to be rejected. So so that's the ideal cycle. Now the real cycle is, as I said, what happens in the industry. None of the processes are obviously. Sorry, I'm going back and forth here, but I think I've already talked about the real cycle. The real cycle is where there's no irreversibilities, and the ideal cycle is where there are irreversibilities because it's not real. But the real cycle is what we use in industry. And let me look at my notes for a second. Okay, so so we use the real cycle in an internal combustion engine known as the gas turbine. Okay, so briefly, internal combustion engine. It's car engine, plane, whatever vehicle engine. They're all internal combustion engines, and cars like petrol cars, for example, use something called the Otto cycle. That's the cycle they follow. And then diesel cars use the diesel engines. Sorry, petrol engines use the Otto cycle. Diesel engines use the diesel cycle, and then gas turbines use the Brayton cycle. And what else is there? And then steam turbine uses the Rankine cycle. That's just four for you. So in this case, with the Brayton cycle, we're talking about the gas turbine, because the gas turbine actually, as I said before, is based on the Brayton cycle. So essentially, all the processes are the same. But because it's the real cycle, you obviously have all these losses. So in short, how the gas turbine works is this. In a gas turbine, you have an inlet, you have a compressing stage or compressor section, you have a combustion section or a combustor, depending on what technology you're using. You have an expansion section, which is the turbine, the actual turbine, and then you have, in the end, the last thing you'd have is a generator, and you have transformers and whatnot. But that's going into electrical engineering, so I don't want to go too much into that right now. So how it works is atmospheric air is drawn into the compressor through the inlet. So the inlet sucks in the air, and then and when it gets to the compressor, the air is compressed to high pressure, because you need high pressure in order for combustion to take place in the combustion chamber. So when the air is compressed to high pressure, this air goes into the combustion chamber, while the fuel and in the gas turbine, you can use diesel or distillate fuel, whatever. It's diesel, light crude oil, or natural gas. It's what those three I know for a fact you can use in gas turbines. But so let's just say you're using diesel or whatever. So whatever fuel you're using, and the fuel is injected into the combustion chamber through what we call fuel nozzles. So but I'll explain all that later on in another video where I'm going through the technologies. But so once they're injected, and where the air is also injected, all these are injected in a very interesting ways. But as I said, I'll explain that later on in a more detailed video. So they're injected into the combustion chamber, and where there's a fuel-air mixture, and then in most cases there are spark plugs that are ignited to help create this combustion within the fuel and the air. And once this happens, the combustion takes place. And when combustion takes place, the combustion creates this what is known as HFG, hot flue gas. So hot flue gas is the gas that you need and this gas goes into the turbine section, and the turbine has different stages. So depending on what kind of turbine you have, you'd have different stages of turbine stages. The blades that are done in a certain way in each, and there can be different stages. So some turbines may have 4 or 5 stages, or some may have 3 or 2. So what happens is this hot flue gas goes into the turbine and starts to rotate these basically the turbine begins to rotate because of the hot flue gas, which in turn starts to rotate what is known as a shaft. And the shaft is a cylindrical sort of thing, metallic thing. It's ridiculous steel that's being used, and that basically, just imagine a shaft is like this, and basically the gas turbine basically sits, all the components of a gas turbine sit on the shaft. It's ridiculous strength that's holding everything, and this shaft is rotating at a ridiculous speed. And as I said, I'll explain all of that later. So that's what's happening here. Now, to link that to the Brayton cycle, what's happening here is the first stage of the Brayton cycle was the compression stage. So that's the stage where obviously the air is being compressed. So that's stage 1. So 2 is the heat addition, and that's the combustion stage. So that's stage 2. And then stage 3 is the expansion stage, which is the turbine, where the hot flue gas is turning the turbine. And what happens is, as the hot flue gas goes into the turbine, it expands. The hot flue gas is expanded in the turbine. The turbine expands the gas, so the volume increases and the pressure reduces. So pressure is reduced. So the turbine and the compressor work in almost opposite ways. In that the compressor usually starts off as large and then goes down kind of like that. And then the turbine starts off small and then goes up kind of big. So in the compressor, volume is reducing, and in the turbine, volume is increasing as you go along in each stage, and pressure is reducing. And okay, so that's stage 3. Now, the fourth one is the heat rejection stage, and that's the exhaust side. So not all the gases, not all of the gas from the combustion goes into the turbine. Some has to go to the exhaust, and that's the heat rejection side. And this heat rejection goes into the atmosphere, which is where we have the, what do you call it? Which is where the cycle becomes a real cycle, whereby this heat is being rejected. It's basic thermodynamics. That heat has to be rejected, and that's the stage 4 for the Brayton cycle. Now, an easier way to understand the Brayton cycle and the gas turbine, how it works simply, is these 4 words. Just remember these 4 words: suck, squeeze, bang, bang as in B-A-N-G, bang, and then blow. Okay, so now let me explain what I mean by that. Now, the air is being sucked into the compressor. In the compressor stage, air is being squeezed. Now, in the combustion stage, there's bang. There's an explosion, basically. That's what happens in the combustion chamber. It's like an explosion when the boom, fire, whatever. And then the blowing comes in the turbine section, where the air is being blown. It's like a fan. So air is being blown from one stage to another. Just imagine how the turbine blades are designed, is that air is being blown from one stage to another. So there's blowing going there. So suck, squeeze, bang, blow, in those gas turbine sort of Brayton cycle situation going on there. So, okay, let me, one more thing. Right. I guess we could say the processes that are also taking place. I guess we have mechanical energy, thermal energy, kinetic energy, chemical energy. There you go. In the combustion state, the fuel combustion. Boom. All right, guys. yeah, so that's my explanation for the the Brayton cycle gas turbine. I mean, if you have any questions, just let me know, and I'll see how I can explain it further in terms of real life and what we learned, because I realize that it's so much different. You know, when you've worked in industry, the gas turbine, and seen it and realize how much it's not that it's different from what you've learned. It's very similar to what you've learned, but the reality of how it works, you know, what's involved in the technology that's being used is very interesting, and I'll definitely do more videos to explain further the technologies that are involved in using in a gas turbine. But yeah, guys, please like, subscribe, and send me any questions you have in the comments below. And hope to see you soon. All right, bye bye for now. Bye.